Hi there, we are now on lesson 16, which is looking at the symmetry in the coordinate plane. And so opening exercise, let's see, given an example of two opposite numbers and describe where the numbers lie on the number line. How are opposite numbers similar and how are they different? So I think when they're talking about opposite numbers, let's make sure I've got my pen on. I'm thinking of like, here's 0, here's 2. So kind of opposite is -2. That's what I'm thinking about. They're opposite because they're both 2 units from 0, right? But one is going to the right and one is going to the left. They're on opposite sides of that 0 on the number line. And then the other thing is the absolute value of -2 is 2. The absolute value of 2 is 2. So they also have the exact same value given absolute value. They're different because they're on opposite sides of 0 on a number line. Okay, so I said a lot that I didn't write down, but anyway, I'm going to move on. And then example 1, extending opposite numbers to the coordinate plane. Now let's see if I'm thinking, if I locate and label your points on the coordinate plane to the right, that's so small, isn't it? Oh my gosh. Let's see if I can enlarge that a little bit. For each given pair of points in the table, record your representation, conjectures, in the appropriate cell, blah, blah, blah. Pay attention to the absolute values of the coordinates and where the points lie in reference to each axis. Okay, and we know this is x, this is the y-axis. So I'm going to look at 3, 4, they're saying, and then -3 and 4. Okay, I'm looking at those. First question is, what are similarities of those 2 points? Well, they have the same, right here, boom, boom, the same y coordinate. When I'm looking at the 4 and the 4, we've got 1, 3, 1, -3, they go in opposite directions. The x coordinates have the same absolute value. So x coordinates, same absolute value, right? Okay, let's see. How about the difference? X coordinates are opposite. X coordinates are opposite. Got it. Okay, then let's take a look at 3, 4. Got it already plotted. Done. And 3, -4. So those two should almost change that so that I see that I'm dealing with 2 different points. Okay, so now we're over there. It says, so they have the same x coordinate, the first coordinate, okay, and then the y coordinate equals same absolute value. Okay, so and then what are the differences? It says, well, the differences are that they are both 3 units. Let me think. 1, 2, 3, 1, 2, 3. They're 3 units from the y-axis and 4 units away from the x. So let's see. 3 units away from y-axis. I should put a line there. And then they're 4 units away from x-axis. This is a little more writing than I thought we'd do. Okay. Then I have, let me change my color again for a third set of coordinates. So over 3 up 4, so we've got that one. And now -3, -4. Wow, look at we're in opposite. We're over here in quadrant 1. This is 2. This is 3. And this is 4, Roman numerals. Okay. So now, what could we say is similar with those two? Let's see. Well, I know that those are opposite, but absolute value that have the same. So the the x coordinate, let's go x coordinate, same absolute value. And the y coordinate is same absolute value. Oh my gosh. Okay, so that part's good. Then it says, what are the differences? Well, both the x and the y are, let me look at that. Both the x and the y are opposite numbers. Both x and y, meaning in each set, like 3 and -3 are opposite. 4 and -4 are opposite numbers. Okay, got it. Then let's see, do I go, let's next page and see. I think there's part of my chart was on this page. So that's okay. You'd still be looking at your whole page. So the similarities in 3,4 and -3,4, both points are 4 units above the x-axis and 3 units away. So see if I can write that. So four units above, it says the x-axis. My writing is not so great right there. And then 3 units away from y-axis. It's not a very big box to write a lot of stuff in. So that's kind of a disadvantage for this. Okay. Let's take a look at, maybe I should go the difference in the location for the 3,4 and the -3,4, which is that first column. 1.3 units to the right of the x-axis, the other 3 units to the left. So 3 units to the right, and 1 is 3 units to the left. And then relationship between the coordinates and location on the plane. The x coordinates are opposite numbers, so 3 and -3. So they're on opposite sides of the y-axis. And they're opposites, but they have the same absolute value. They lie in the same distance above the x-axis as the y-axis. The points are symmetric, okay, and they reflect across the y-axis. You probably covered that in 5th grade too. So I talked it, I didn't write it because that's just too much. When we get to the 3,4, 3, -4, similarities, both points are 3 units to the right. So 3 units to the right of the y-axis. And then 4 units away from the x-axis. See, to me, that's just too much right in there. And the difference in location, 1 point's 4 units above the x-axis, and the other's 4 units, so 4 units above, 4 units below. That's not so helpful. Okay, and then when we have the relationship between the coordinates and location on the plane, The y coordinates are opposite numbers, so the 4 and the negative 4. And they're opposites, but they also, again, don't forget, have the same absolute value because they're the same distance from the x-axis, okay? Let's go over to 3, 4, negative 3, negative 4. So those are kind of diagonal from each other. So similarities in location, both points are 3 units from the y-axis and 4 units from the x. So 3 units from y-axis, and then it was 4 units from the x-axis. Okay, and then what is the difference in their location? One point is 3 units to the right of the y-axis, the other is 3 units to the left. One point is 4 units above the x-axis, and the other is 4 units below, which means that, again, if you've got the opposite, if you've got the absolute value of those opposites, they end up being equidistant from the axis. So, and then there's also reflection across the other axis. So that's a ton. I didn't write in for the difference. Oh well, that's okay. You know what? We're doing all right. Now I'm going to scroll down here to the exercises. In each column, write the coordinates of the points that are related to the given point by the criteria listed in the first column of the table. For example, point S, which is 5 over 5 up 3, has been reflected over the x and the y axis for you as a guide. And its images are shown on the coordinate plane. Use the coordinate grid to help you locate each point and its corresponding coordinates. A little confusing, but let's see if we can try this. So they're saying that if I go, S is over 5 up 3, got it, the given point is reflected across the x-axis, right? Reflected, so boom, we're at M. So I'm going to write M, let me go for a darker, I'm going to write M, but then what I'm also doing is I'm going over 5 and down negative 3. Okay, and then I wonder if I should stay with that one. The given point, so S, is reflected across the y-axis, so then I end up at L, right? Reflected, so like a mirror. So now I'm at negative 5 up 3. Okay, I'm going to stay with that point S. I'm going to stay with this one for this next question. It's reflected first across the x-axis, then across the y-axis, so I'm over at A. And A ends up being a negative 5 and a negative 3, because I'm in the 1, 2, 3rd quadrant. Then go back to that original S. This is reflected first across the y and then across the x. Well, I'm back to A. And that's a negative 5, negative 3. Okay, got that. So that works for me to stay with 1 point. So the next one says go over negative 2 and go up 4. Well, negative 2, that's the point that they've given me. So if I take that and I reflect across the x-axis, I'm going to end up with a point down here that is 2, 4. So I think what I can first do is I'll write in negative 2, negative 4. If negative 2, 4, reflect across, I'm at negative 2, negative 4. Okay, so now I go back to my original point, and I'm going to go reflect across the x, yep, and then across the y. So now I'm at 2, negative 4. So that's what I'm going to write. Wait, am I at 2? Wait, let me go back and look. So negative 2, 4. And it says I'm first, wait, I didn't do that right. I think I jumped down to the bottom one. It's reflected across the y. So now that is just a 2, 4. Okay. Then let me go back to this other one. So I'm starting out at negative 2, 4, and I'm first going across the x and then over to the y. So that one is going to be my 2, negative 4. 2, negative 4. Got it. Now, last thing, okay, I'm going to go back to the negative 2, 4. I'm up here. And I'm going to go across, I'm reflecting across to the y and then across the x. So I end up down here. So that's it over 2, and it's a negative 4. 2, negative 4. Okay, this is a little kind of slow going, but that's all right. So then I'm going to go to the next point, which is 3, negative 2. Whoops. 3, negative 2. Okay. So let me do it. 3, negative 2. Got it. Okay. I plotted my point. Now I have to reflect across the x-axis. So this is going to be a 3, 2. Okay, what if I take my original point and I go across the y-axis? Now I'm at negative 3, negative 2. Okay. Then if I go from my original point, I keep clicking off the deal. If I go 3, negative 2, and I'm going to go across the x and then across to the y, and now I am negative 3, 2, positive 2. Then I'm going to go back to the original negative, or 3, negative 2, go there, go across the y, boom, and then across the x, boom. I'm at negative 3, 2. That's interesting to me that those keep. Okay. Whoa, last one. Oh my gosh. Okay. This is a negative 1, negative 5. I'm all the way down here. I should use another color, but that's okay. Now I'm going to go across the x-axis, so I am at a 1 and negative 5. Okay. Then, did I do that right? If I go, let me look. If I go negative, negative, here I'm at this point. And then I'm going to go across the x. Oh, wait a second. I'm going to end up here. I'm going to end up negative. So I have to undo that. I had a little, I jumped the gun just a little bit. Let me just clear that and then do this again. Okay. So I was negative 1, negative 5 right here. And then I go across. So now I'm negative 1, 5. Negative 1, 5. Okay, now let me go to the original point, negative 1, negative 5. Go across to the y. I just did that. I went across, no, that was across the x. Now I'm going to go across the y, and now it's a 1. It's a 1, negative 5. Then back to my original point, I go across the x, got it, and then across the y. I don't think I have one of these points. It's a 1, 5. 1, 5, got it. Okay, then go back to my original, go across the, across the y first, then I go across the x, so I'm back to 1, 5. Wow. Okay, let's see. How are we doing there? I think we have that done. Let's see what the next page says. The next page says, when the coordinates of 2 points are x, y, and negative x, y, what line of symmetry do the points share? Let us see. I'm trying to think about this. Oops, I'm getting a little. When the coordinates of 2 points are, so let me just throw in, like, let's say it's 2, 3 and negative 2, 3. So I have over 2 up 3, and then I have negative 2 up 3. What line of symmetry do the points share? Well, I will be darned. I am looking back. They share, so this is my X, this is a Y. They are sharing, I mean, they have the same Y coordinate, right? That's the 3. The Y coordinates are the same. The X coordinates, so Y coordinates are the same. X coordinates are opposite, but you know what? Remember the absolute value? If they're the absolute value, they're equidistant from the y-axis, right? Jump here, and I've got 2, and I jump here, and I've got 2. So, okay. When the coordinates of 2 points are x, y, so I go x, y, and x negative y. Okay, so now they are, what line of symmetry, boom, 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 do those points share? They share the, here's my x, here's my y. They share the x-axis because they're equidistant. They just go in opposite directions, right? One is up from the x-axis, one is below the x-axis. And the y-coordinates, so x are the same, y are opposite but equidistant. Let's see. Yeah, yep. What line of symmetry do the points share? So they are equidistant from the x-axis. They just happen to be, one is up and one is below. Okay. So, examples 2 and 3, navigating the coordinate plane. This looks like I'm going to have problems on this page, but let me just see where we're at. Using a pencil, navigate. So going to plot over 7, 1, 2, 3, 4, 5, 6, 7, and up 2, 7, 2, move, okay, this is just like directional, move 3 units down, 1, 2, 3, and then it says, reflect over the, here's my X, here's my Y. So move 1, 2, 3 units down and reflect over the y-axis. So 2, 4, 6, 7, 2, 4, 6, 7. So that would be my new, if this was whatever point, if we gave it a name, it's now over here. Okay. Where did we end up? We ended up at -7, -1. So this original point was 7, 2. Okay. So let's begin at 4. 1, 2, 3, 4, -5. 1, 2, 3, 4, 5. So that is 4, -5. And we're going to reflect over the x-axis. So 4, 1, 2, 3, 4, 5. So now we're at 4, 5. Okay. And then move 7 units down. 1, 2, 3, 4, 5, 6, 7. 7 down, and then to the right, 1, 2 units. Okay, that's the new point. Where are you? You're at 1, 2, 3, 4, 5, 6. You're at 6, -2 is where you're at. So I will be darned. I mean, kind of fun. Let's see. I think I just saw a sign saying, you have 10% power. Does that remind you of your Chromebooks? No, maybe not. Okay, let's do one more. Actually, I'm going to go grab a power cable, but let's do 5, -1. So 1, 2, 3, 4, 5, -1. So we're starting there. 5, -1. And then we're going to reflect over the x-axis. So if I'm at 5, -1, I'm now at 5, 1. Then it says reflect over the y-axis. So now I'm going to go 1, 2, 3, 4, 5, up 1. So now I'm -5, up 1. I'm going to go get the charge cord, and then we will do maybe one more move. I know, I was just thinking about, I think I had a student the other day, they were taking a map test. I know not all of us did that, but I think their Chromebook died while they were busy taking their test. It's like, oh my gosh, that could be bad timing, wouldn't you say? Okay. So this is kind of fun, but I think we're going to stop on that. Because basically we are navigating the coordinate plane using reflection. Reflection is really fun in art too. If you've not done translations, there's an art project that's really cool with translating shapes, anyway, we'll have to do that. Okay, so this one is describe how to navigate this coordinate plane. I wonder if I should erase this stuff. If I erase all this, and then I think we're doing one more activity. So let's say if we begin at 9, -3. So 2, 4, 6, 8, 9, and then we said -3. 9, -3. And we end at -4. 1, 2, 3, 4. 1, 2, 3. -4, -3. That's where we end up. Use exactly one reflection to get there. Oh my gosh. Well, you know what? If I reflect, so this is a 9, -3. So if I were over here and I did a -9, -3, let's just say I was there. 2, 4, 6, 8, 9, -3. So if I were here and then I move in 1, 2, 3, 4, 5 units, I would then move 5 units, then I would get there. So reflect over the y-axis. Let me go, here's my x, here's my y. I reflected over the y-axis, boom, like that. And then I backed it up 5 units, but I stay on this 9, and I'm down -3. I'm still down with that 3. It was -3. Okay, so let's try one more. Let's begin at, just for fun, 0, 0. Okay, and we're going to end up at -1. 1, 2, 3, 4, 5, 6. Negative. We're going to end with -1, -6. Okay, using exactly 2 reflections. Okay, so if I'm here and I move right 1 unit, and then I reflect over the, well, if I'm at 0, 0, and I move right 1 unit, I reflect over the y-axis and up 1, 2, 3, 4, 5, 6, up 6 units, and then reflect over the x-axis. That's true. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. Okay. And then what is that going to do? Because I was at -1, -6. But maybe I wanted to go over here. If I go over here 1, go up, that's equidistant. If I go over 1 and then drop down, -1, -6, or if we reflect over to, if we reflect over the y-axis, I'm trying to figure out if we are at our 0, 0, 0, 0, we go move right 1 unit. We did that. And then reflect over the y. Reflect over the y, yes. And then move up 6 units. I guess that would be a reflection. We could call that. It's a little confusing, I think. Just a little bit. But you know what's really important is that we can plot the points on the coordinate system, right? And we know the difference between 1, 2, 3, and 4 in Roman numerals. And we know what a negative coordinate point is going to be, right? So, I mean, there's a lot in this lesson to me. So let's see. I think we're done with this and we're ready to move on. So way to go to bear through this.